Hi everyone, and welcome to our online meetup. In today's meetup, we will demonstrate how we're building a simple microservice using Node.js and Docker. So first, for those who this is the first time joining us in this meetup is a 30 minutes webinar, which is a mainly demo most of the time, plus 10 minutes in the end for question and answer. All the sessions are recorded, and we will send a link to the recording afterward. In addition, we highly encourage each and every one of you, if you want us to talk about specific topic, please put it on our message board. We also encourage you, if you want to give a talk yourself, we not only open to it, we encourage it, so feel free to post and position yourself. About myself, so hi everyone, my name is Raziel. I'm first a developer, entrepreneur, and very passionate about new technologies. I live here in the Silicon Valley since 2008, and I'm the founder and CEO of CodeFresh. CodeFresh is a member of the Node.js Foundation, and CodeFresh is sponsoring this meetup and sponsoring the recording. A few words about what we do in CodeFresh. So CodeFresh is a Docker platform for dev team. It basically allows team to build, run, and test Docker containers. You can simply click on any pull request, branch, or commit and get it running within a Docker container and test your features immediately. Our beta program is now open, so you may check us out at codefresh.io. So what we will see today, we will follow the steps required in order to create an image with a microservice in it. The first step will be to run a Docker container that has Ubuntu. So in order to do that, we're going to go and search for a Docker image with Ubuntu. In Docker Hub, we're going to run an instance of this Docker container. On top of it, we will install what is needed in order to run a Node.js application, and we will create a base image, a new Docker image that includes both the Ubuntu and the Node.js installation. Then the next step will be we will build a microservice locally using Express and Node.js. We will test our microservice, and after that we will copy our microservice and run it from within a container that we create from the new base image. Once we tested and our microservice is running well, we can go ahead then and create a new image that includes all of these layers, the Ubuntu, Node.js, and our microservice. Then the last step that we're going to do today is actually take our new image that includes all of these layers and publish it in a Docker Hub registry. Before we getting into the demo itself, for those who are new to Docker, I'm going to briefly give an orientations on the Docker terminology that we will be using heavily today. Docker images are basically blueprints of our applications. We can create containers, which is a running instance of our application out of these images. So basically containers is a running instance of an image. We have Docker daemon, which is what is doing the heavy lifting of building, running, and distributing containers. Docker client, which is the component we have locally that connects and interacts with the Docker daemon, and Docker Hub, which is a registry of Docker images. I also highly recommend to go to the link below. It's a very good blog that describes this even in more detail. Okay, so let's go to my terminal. And I'll start by saying I'm running all of these demos on my Mac. And in order to do that, I have pre-installed boottodocker, which has the Docker daemon. It's the Docker host, and it allows me to run Docker containers on my Mac. So we'll start by checking boottodocker version. So we're running version 1.7.0. We can check the boottodocker status, and we can see that we have boottodocker running. Okay, so the first thing that we're going to do is we need to run, as we said, an instance, a Docker container with Ubuntu. So let's see which Docker images we have on our machine. So I will run Docker images, and in fact I'll see that I don't have any Docker image on my machine. So what I need to do is I will have to go and search for Docker image with Ubuntu and pull it and run it on my machine. So the way to do that is we will just run the command docker search, and we'll search for Ubuntu. So I run docker search. I got all of these options, and we can see the different images name, their descriptions, and the number of stars. And the number of stars to some level can indicate the popularity of that image. We can even refine our search by telling Docker search, give us only a result that has 1,000 stars and above. And we'll do that by the flag -s and then 1,000 and then Ubuntu. And then we can see that we're going to get only one result here, which is the first image of Ubuntu with more than 1,900 stars. Okay, so now we actually need to run two steps in order to get a running container from this image. We need first to pull that image into our machine and then to run a container from that image. There are two different commands. There is docker pull that we can use and then docker run. But in fact, Docker is also allowing us to combine these two commands into just running docker run, and then Docker will search for this image locally. If it will not find it, it will actually go to Docker Hub, search for it, and pull it from there. So let's do that. Let's run docker run, and now we will give the run command two additional parameters. One, -i to capture the standard input of this container, then -t to associate a terminal, a TTY, to this container. Then we're going to give we will specify the Docker image we want to run, which is Ubuntu, and then the command that we want to run, which is in this case bin bash. Okay, let's see what Docker is doing. So Docker first tried to look for that image on our local machine. It didn't find it, so it basically went to Docker Hub, it searched for that image, it found it, it pulled it, and then it ran it, and now we're in fact running inside this container. So if I'm typing here ls, I can see all the files that we have within the container that we've just run. Okay, so we have a container, we have a running instance of Ubuntu image. Let's install in this container everything that is needed in order to run a Node.js application. So for that, we will create a script. Let's call it install node. And let's write all the commands to install Node.js. So we'll run first update to get the latest of Ubuntu, then update install Node.js, then we will install Node.js legacy, then the last thing is we're going to install npm. Okay, that's it. And now let's run our script. And as we speak, what is happening is that we are starting the installation of Node.js on this container. Now this might take a minute or so, so let's take a step back and understand what we did and learn a little bit more about Docker images, Docker container, and Docker run. So for that, I will open a new terminal. And let's start by running the first command that we ran today. Let's run Docker images. In fact, when we run Docker images now, we can see that now we do have a Docker image locally, which is the Ubuntu image that we pulled from Docker Hub. Another command that we want to run is docker ps, which will list all the running container we have on our system now. if I run docker ps, in fact, I can see that there is a running container. This is the container ID that has been assigned by Docker. This is the image name that this container has been created from. This is the command that we run when we started running the container, and we can also see the name that Docker has assigned to this container. Let's run another container. In fact, we can run as many containers out of the very same image, and every container will be a fresh container with the same status of the image. One container will not affect the other. So let's run docker run again. But in this case, we're not going to capture the standard input and assign a terminal for this container. We can just run it in the background. So in order to do that, we will give the docker run command the -d flag. And then let's also assign ourselves a name to this container. So we can do that by the --name and give it the name my container. Then we will specify the image that we want to use, in this case Ubuntu as well. And the command that we will run in this case will be sleep 15 seconds. That's it. Let's run it. And in fact, Docker have run this this container now in the background. Let's run docker ps again, and we can see that at the moment we have two containers running with two different IDs. They're both from the Ubuntu image. They have different command and they have different names. We can see that in the last one we've actually gave the name of the container ourselves. Okay, so now let's go back and see what's the status of the container in which we install Node.js. Okay, so in fact the installation has completed. Let's actually see that we have Node installed, so we'll run node -v, and yes, we have successfully installed Node.js on this container. Let's exit from this container by tapping the exit command, and now we're out. And now we actually want to create a new Docker image from the container that we just installed Node.js in it. So the way to do that is by running the docker commit command. But one of the parameters we needed to give docker commit is the container ID. So let's look again at docker ps to get the container ID. So I'm running docker ps, but in fact now I don't see any container here, and that's because both containers exited. So I can run docker ps with the flag -a to get all the latest containers. And now I can actually see here the two containers that we ran before. So here is the container ID, and now let's start by running running the docker commit command. Docker commit, and we're going to give the flag -a for the author, and that will be LZLT. And now we'll specify the container ID. We don't have to give the full ID. We can in fact use only the first 3 to 4 letters. So let's use 22D, and let's give our image a name. We'll call it Ubuntu Node and give it a tag of 0.1. Okay, that's all we need. We run it, and Docker have just created an image from the container with Ubuntu and Node.js. So let's just make sure we run docker images, and yes, we have now two containers out here, Ubuntu and two images, Ubuntu and Ubuntu Node, which we just created with Node.js on it. Okay, let's go back to the presentation and see what we've done. So far we just created a base image. So we have pulled out, we search for Ubuntu image in Docker Hub, we run an instance of it, we install Node.js, then we took the container with Ubuntu and the installation, and we created a base image. We call it Ubuntu Node with these both layers. The next step will be, let's create a very simple microservice application, and we're going to do that using Express and run it, test it before we port it into the Docker container. So let's go back to the terminal. And I have pre-installed on my own Mac Node.js and also Express Generator. For the one who don't have Express Generator, the way to install it is by running npm install -g Express Generator. But I already installed it, so I can simply just run, I'm going to run Express. We call it my microservice. And in fact, we can see that Express have created a folder with all the files. Let's go into that folder. And we can see that we have all the files here for a very basic Express application. The next, I'm going to open WebStorm IDE, and we're going to make some adjustments, some modifications to this application. We're going to add an API that will be the service we will demonstrate today. So let's go to WebStorm. And let's open our microservice. Okay, let's start by looking at the package.json. In fact, we can see that the start command is running node, and the file is .bin www. Let's see what's in it here. We can see that here we're loading the app module, and then we start listening on the port, which is by default 3000 unless specified differently. Let's go to the app module. We can see that here we're loading two different modules, index and users, and we're using them here. Let's create our own module. In this case, we'll call it an API. So for that, we're just going to do file, new JavaScript file, call it API. Let's copy whatever we have here, and we'll just make some adjustment. We're going to call our function greeting, and that will be here, say hello, and the message that we're going to reply will be hello meetup members. Okay, that's it. We added a function. Again, in today's meetup, we're going to do something very, very basics. In the next meetup, we're going to go a little bit in more details into what are the best practices of microservices. But for now, let's just add this function. Let's load it and use it from within the app.js. So here, we'll just copy paste it, call it API, loading our API.js file. Let's use it here as well. That's it. So this is all done. Let's see that our service is actually running. So let's go back to the terminal, and here let's run npm install. Now npm will bring all the required module in order for a microservice to run. Now we're going to run npm start, and here it's running. Let's open it in a browser and see that we have our function running. So I'm going to open a browser. So we are on port 3000, and here we have it, API say hello, and here we go. We have our function call, so our service is now running. We have our service running locally. Let's see now how we can create a container from the new image that we created that has Ubuntu and Node.js, and have this service running from within that container. So let's go back to our terminal. Let's stop our service. And let's learn about additional parameters that we can give the docker run command. First, let's run docker images. Again, the name of the images that we have. Let's run the command pwd to get the full directory that we have our microservice stored in. And now what we're basically going to do, we would like to run a container of this image, of the Ubuntu node image, but we want to have our service available from within that container. So how we do that? We're first going to run docker run command, and we're going to give it the flag of -i for the standard input and -t, or we can combine them as -it. And then we're actually going to use another new flag, which is -v, to mount volumes from the host to the container. So let's mount the folder, the local folder in which the service is stored, and we're going to mount it to a local folder in the container that we're going to give it the name host. Okay, the next parameter that we're going to learn about is -p. -p help us map the port of our application in a container to the port that the host is exposing. So we will actually map the host port of 9000 to port 3000 that our application in the container is using. Then the next parameter will be the image that we want to run. So Ubuntu node with the tag 01. And then the command that we're running is bin bash. Okay, so what happened now, we've actually created an instance, a Docker container from that image, and we mounted the volumes of the local volume at the host to that container. Let's see that. Let's run ls. And actually we see that there is a folder here named host. Let's see what's in host. And here we go. We have our microservice code within that container. Now it's important to note that the mounting itself is happening temporary for this Docker run execution. In order to keep that in that container, we need to copy these files into a local folder within the container. So let's do that. Let's run cp -r. We're gonna copy whatever in the host directory into new directory that we called microservice. So we run it, and in fact we are copying now all the files. Okay, now let's go into the microservice folder. We have our service here. Let's run it. So that's it. We have our service now running within the container. How we can test this service? What's the way to get to this service now? In order to do that, let's go back to a new terminal, and we'll learn about a new command, which is boot to docker IP. This command will actually give us the IP that our Docker host is exposing. So this is the IP in which our container can be accessed. Let's take this IP. Let's open it in a browser. Now, we need actually to go into port 9000 because we have mapped 9000 to the 3000 of our application. Then let's go, and we have it here, the API and the say hello function, and run it. And here we go. We've actually managed to access our microservice that is running now within the container. Excellent. Everything worked. So now when we have it running, let's exit. And let's go through the step again of creating a new image that at this point also not only including Ubuntu and the Node.js installation, but also including our microservice. So let's run docker ps and we'll give it the -a to get the latest container that ran. And now we have the container ID that we want to use for the Docker commit, so we will run docker commit. We'll run docker commit, and we're going to give the flag -a, LT as the author, then the first three letters, which is B4E, which is enough at this point, and let's give our container, our image, a name, and we'll call it node microservice, and 0.1 will be the tag. Okay, we run it and we created a new image. Let's run docker images command, and we can in fact see that there is a new image created called node microservice, which is in fact including the Ubuntu, the Node.js installation, and our microservice. Let's try running it in the background and see that it's all working. So I'm going to run docker run again. By the way, there is one important comment to make. Creating an images using docker commit and docker run, it's one way. There are various other ways that we will cover in future meetups to create Docker images. There is obviously a way to use Dockerfile, which is sort of a recipe of how to create an image. We will cover that as well, not in this meetup. In this meetup, we're really focusing on the command line and how powerful the command line of Docker are, and we can create images, run images, attach ourselves to an image, and so on. Okay, so let's go back. Now we're trying to run our image with a microservice in it. So we'll do docker run. We will run this docker in the background. So we'll specify the flag -d. Now, one more parameter that we can run, we can actually, as part of the docker run, we can tell Docker what is the working directory that we want the command to be executed in. In our case, we actually located our service, our microservice, in a microservice folder. So we'll specify -w for the working directory, then microservice folder will be our working directory. Then we will give the Docker image name, which is node microservice 0.1. There is another parameter that we need to add here, which we didn't, which is again the port mapping. So -p 9000 to 3000, the name of the image, and the command will be npm start. Now let's run it, and in fact, yes, we have our service now, our container now running in the background. If we run docker ps, we can see that we have the container in the background. We can see the command that we run. We can even see the port mapping of 9000 of the host, which is mapped to 3000 of the application. Let's test again and see that our service is in fact running. So we're in the same IP. Let's click a refresh. And yes, we have our application, our microservice running inside the container in the background. Let's go back. We can see that although we run it in the background, Docker allows us to reattach ourselves into this running container by calling the command docker attach and specify the container ID 3D61. Again, we can specify only 3 to 4 letters, that will be enough. And now we actually attach to that container, and all the and we capturing the standard output of this container. So if we go back and we're going to call this function again, we can in fact go back to our terminal and see the output of this container. Okay, let's get out of this container. Now we see Docker PS. We have no container running. We have created an image with our microservice in it. Let's recap it. So what we did so far is we have created a base image with Ubuntu in Node.js. Then we created a microservice. Then we copied that microservice inside the container. Then we created a new image that include all of these layers. The last step will be to populate our Docker image of the microservice into Docker Hub, so it can be easily consumed by everyone who's searching images in Docker Hub. So in order to do that, first we need to go and have an account at the Docker Hub, which is hub. I will use my account. So you need to have an account, and from the command line I will run docker login, and that's the way for me to connect to Docker Hub. Now when I'm logged in, I can go and push our image to Docker Hub. But before we do that, let's learn about another command of Docker, which is docker tag. As we've seen up till now, the images that we created, we always refer to them with the tag 0.1. If we want to have our images to be consumed in an easier way, we can actually add another tag to our image, which is latest. So we'll do that by docker tag, and we'll add a tag to node microservice 0.1, and we'll tag it as node microservice latest. As we do that, and now we run Docker images, we can see that there is another entry here with latest, and that basically allows everyone to just specify node microservice without the 0.1, and what will happen is that this will actually take the latest, which is 0.1 now, and use it. So there's one more tag that we need to add before we populate it to Docker Hub, which is adding our username to the image name. So we'll do docker tag node microservice, and we can call it RZLT node microservice. Okay, we run it. Let's run Docker images again. And now, in fact, seeing that we have here our tag of RZLT node microservice, and then we just need to run docker push RZLT node microservice, and that's it. That will actually go now and populate our image to Docker Hub. Okay, let's recap what we did. So we have run a Docker container out of Docker image of Ubuntu. Then on top of that container, we have installed Node.js. So now when we had a container with Ubuntu and Node.js, we created another Docker image that includes these two layers. Then we have built locally very simple microservice application using Express and Node.js. And once we had our microservice working well, we've actually run again a container out of our best image and copied our microservice code inside this container. We tested our container now with the microservice in it, and once we've seen that everything is working well, we've in fact created another Docker image that includes Ubuntu, Node.js, and our microservice. The last step was, after we have a Docker image with everything that we need, we've actually went and published it on Docker Hub. So that's it for today. There are additional resources that we will be posting on blog.codefresh.io. I hope you've also noticed that we have changed the group meetup name and location, so now it's Container 101, and the URL for follow-up meetups is under Containers 101 online meetup. We've also maintaining the existing meetups under a different name, Container Node, and obviously we also recommend to follow the Docker online meetup, which is delivered by Docker. Of course, if you have any questions, please do not hesitate to email me directly at raziel@codefresh. You're also very welcome to follow Codefresh at Codefresh on Twitter, or myself at Raziel Tabib. And lastly, as I said, we're running now beta at Codefresh. You're welcome to try it out and let us know how it works. Thank you all, and looking forward to see you in the future meetup. Thank you.